So, in the series of lecture, I will be taking up the topic of reinforcement detailing of various RC structural member or the element as per the prevailing codal provision. So, in the lecture, I will be taking up the reinforcement detailing of the columns in the RC structure. Now, this continuity of the bar in the column. So, here in the left side figure, you can see there are various do not I have shown, and the bottom I am just showing what the do's should be there. So, in the first figure you can see that the bar binder for any mistake or whatsoever he has not planned accordingly to continue the bar that is coming from the bottom story to the top story. So, what he has done? He has left the bar of the column in the bottom story, and again he is now starting a new bar just by giving a kink at the top surface, and hereafter the concreting generally continues. This kind of setup is highly not recommended to be followed or even thought of. In the second case also do not, here we can see there is a small portion is protruding from the beam itself, and what the bar binder does to make the continuation of the rebars, he just waits that next bar from here and continue the concreting. This is also not to be done. So, what we should be better doing is that the bottom figure left side you can see. So, by any mistake we have left the bar to continue to the top story, what best we can do? We can go for a groove cutting inside the beam. The groove cutting should be minimum of a depth of 150 mm, and the bar should be grouted properly, and then it is allowed to continue. On the right side figure, bottom side, we can see another aspect of welding. We can go for a groove cutting, so that adequate weld length is available where the bar can be welded and the continuity of the joint can be maintained. Again, another aspect generally we face in the building while doing a construction for a particular story of the building, there is a requirement to give the space for future expansion. So, you must have seen for the private buildings, the people generally leave the reinforcing bar exposed, so that in a future date the construction can take place and the column can extend. So, but it is the major issue is that whatever the rebars are left under a weathering condition, those corrode over a period of time, and when the corrosion start taking place, it altogether defeats the purpose of the providing reinforcement. And also many places what the people do, they just bend the bar 90 degree just first with the flow, so that it does not create any hindrance in the movement. This is also to be rightly avoided, because this is not the correct thing to do in the structure. So, what we should be better doing? Let us come to see in the right side figure that we have to cast all together that column be a part of a dummy column or a stop column. The reinforcing bar of desired LD or the development length should be given, and the stirrup should be provided, and in the usual manner the concreting should be done. And again, for more safety, what we can do that we can provide a zinc coating on the rebar to avoid the corrosion. Also again, what we can do, we can provide a weatherproofing coat or a waterproofing plaster on the stop column to avoid the ingress of water, so which will resist the corrosion. Now, coming to the lapping of the bars in the tension member. So, at times the compression member, that is generally called the column, are used or subjected to the tension, or it behaves in a manner that it acts as a tension member. We can see the forces are now acting on the outside direction. So, the column behaves in this situation as a tension member. So, basically what the people do on the ground, like the engineers or the bar binder, is that they generally take this as a part of the column and provide the development length LD at the point of lapping. So, this to be understood by the ground executive that being a tension member, the requirement as per the codes are different and it should be followed in the true spirit. So, now coming to the right figure, we can see the first one, we have to ensure that whatever the lap junction is given, lap length is given, that should be at least 2 times the design development length, and the stirrups whatever is coming inside the column, that should be halved at a spacing between these overlapping length portion. So, this will ensure the rigidity of the joint in the lap portion. On the right side, another figure is there where the welding has been introduced. So, in this case what we can do, when we are doing the welding, we have to see the welding length should be 10 times the diameter of the larger bar. So, this will also suffice the requirement of the code. Now, coming to the detailing of the footing. So, here we can see there are various codal provision exist for good detailing of the footing. So, here we can see the two types of footings are there, one is the pad footing and another is the slope footing. So, when the slope is given to the footing to meet the design criteria, when the slope is less than 20 degree, we can allow the single formwork which is cutoff for the pad portion of the footing. So, this 20% within 20% the mason would be able to provide the slope, compact the concrete, everything required he can do. But it is seen on the ground that when the slope becomes more than 20 degree, it is very difficult to maintain that slope or put the concrete in the slope and compact it altogether. So, when the slope is getting more than 20 degree and the ground executives has to ensure that the double formwork setup is used to maintain the proper slope of the footing. Another requirement is there, like whatever the bars or the dowel portion of is coming inside the footing, it should be at least a length of 300 mm all the side. So, we have to ensure while the bar binder cuts the put inside the footing, we have to ensure that is giving this adequate dowel length inside the footing. Another aspect is there in the footing that the whatever the compression bar are coming inside the footing, they should be the compression length should be at least the LD. So, if it is only a pad footing, at times the compression length requirement as per the code is not met. So, for that purpose generally a pedestal has to be given. Many times the structural designer themselves they forget to mention this point and the ground executive has to ensure accordingly the compression length of the column is at least LD inside the footing. Now, coming to a important aspect, that is the column transition. Here in the figure I am just showing the how the column transitioning should be done effectively. So, here you can see in the first figure, now the reinforcing bars are now coming and going above the story, and here the dimension of the top story column and the bottom story column all together are the same. So, there is no requirement and the bottom story rebar can be taken off directly, avoiding the junction where you should not be providing any lap length, and on the top we can provide the lap length. So, here providing the lap length, we have to ensure the bar alignment or the rebar alignment in the column from the bottom story to the top story should be maintained in a single line. So, for that purpose what we can do, the top story bar can be given a kink of a slope not more than 1:10 and it should be matching with the lap length. So, at this lap length portion we have to again provide the stirrup at half of the spacing to maintain the integrity of the junction. And in the right side middle figure, if we are coming to see, we can see now there is a dimension change in the column of the top story and bottom story. The bottom story column dimension is more than the top story. So, in this case what we have to do? We have to ensure again that whatever the bars are coming from the bottom story, those are given a perfect transition or a smooth transition, not the slopes not be exceeding 1:10 and it is taken inside the top story column cage. So, from the top story column we can very much ensure that whatever the rebars are provided, they should be following a single line of alignment. We can see in the figure how the reinforcement is given, and same time again we have to ensure the ties or the spacing of the ties in this junction area should be half than the usual spacing of the stirrups. Now, coming to the next figure, that here you can see that one face of the column is now flushing, that is the exterior face of the column is the flushing in both bottom story and the top story, whereas the dimension of the top story is lesser than the bottom story. So, in this case what we have to ensure, the bottom story reinforcing bar whatever is coming, those are taken a smooth transition inside the top story column, and the transition should not be more than 1:10. And again in the top story the column bars can very well continue to the top and the alignment has to be maintained. And again as usual we have to ensure the stirrups are given half of the spacing than the usual spacing of the stirrup in other portion of the column. Now, in the fourth figure we can see that is one of the different method of providing the reinforcement throughout the junction. Here we can see the bottom parts from the bottom columns are brought and left at the edge of the beam, and the continuity is maintained by providing additional bar whichever is coming inside the bottom story column as well as the top story column. And at the same junction we are providing the ties at a half of the spacing in the both the bottom story and the top story. And the top story column again to maintain the alignment the rebars which are getting continued are given a kink of 1:10, slope more than that, and it should be getting aligned in the single aligned direction of the rebars. So, with this I will conclude lecture on the column reinforcement.